Welcome to the coding interview problem, factorial trailing zeros. You are given an integer n. Return the number of trailing zeros in n factorial. The constraint to this problem is that you have to solve this problem in logarithmic time complexity. How we can solve this problem? First, let me ask you a question. In what situation will you get a trailing zero? Pause this video right here and think about it. When you are done, come back to the video. We will get a trailing zero whenever we multiply a non-zero number by 10. If we multiply this number 1 by 10, then we will get one trailing zero. If we multiply this number 2 by 10, then we see that we get one trailing zero. If we multiply the number 1 by 10 two times, then we get 2 trailing 0. If we multiply the number 2 by 10 two times, then we get 2 trailing 0. So what we have understood? We understood that when we multiply a number by 10, only then we get a trailing 0. If we multiply a number by 10 times, then we will get 10 trailing zeros. Since 10 is made up of multiplying 2 by 5, so another way to get a trailing 0 is to multiply a non-zero number by 2 and 5. So, to count the number of trailing zeros, we need to figure out how many times we multiply 2 by 5. Here we see we multiply 2 by 5 once. So we have here 1 trailing 0. And here, how many times we multiply 2 by 5? Twice. So here we have 2 trailing zeros. Now let's take a look at factorial of 5. The factorial of 5 1 times, 2 times, 3 times, 4 times 5. That's equivalent to 120. In the factorial of 5, we see that we have only one trailing 0. Now our goal is to find how many times we multiply 2 by 5. If we rewrite this, then we see that here we multiply 2 by 5 once. So we have here only 1 0. Since we have multiplied 2 by 5 once, there is one trailing 0. Instead of keeping track number of 2's and 5's, we really just need to keep track of the number of 5's. This is because in any factorial calculation, there are always going to be more multiples of 2 than 5. Here you see we have 3 multiples of 2 and only 1 multiples of 5. So if we can find the number of multiples of 5, then we can get trailing 0 for factorial of a number. Let's take a look at another example for better understanding. For factorial of 10, we have 1 times, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10. And that's equivalent to this number. And in this number, we see we have 2 trailing 0. If we rewrite this, then we get like this. So here we see that we have 1, 2, 3, 4, 5, 6, 7, 8. Total 8 multiples of 2. But we have only 2 multiples of, so if we can find the total multiples of 5, then we can have the answer. Here we see we multiply 2 by 5 twice, here and here. So we have here 2 trailing 0. Our goal is to find the number of multiples of 5. 2 appears in this factorial 8 times and 5 appears only twice. So we can get the number of trailing zeros by calculating the number of multiples of 5. If we are given factorial of 25, then we have to find the multiples of 5, right? To get the number of trailing zeros. Here we have 5 numbers that multiples of 5, and this 25 contains 2 5. If we write this again, then we get 1 times 5, 2 times 5, 3 times 5, 4 times 5, 5 times 5. Here we see total multiples of 5 is 6. So in the factorial of 25, we have 6 trailing 0. Now our goal is to find how many times we multiply the number by 5. Now let's see how we can find that. First, we're going to declare a function trailing zeros that takes an integer number as input. Then we're going to initialize a variable count equals to 0. This variable will hold our answer. Then we're going to run a loop while n is greater than 0. Then we're going to divide n by 5. Then we're going to add that to our count variable. Then we're going to return the count. And this is the pseudocode to solve this problem. For sake of understanding, if you're given the number 5, we know that the factorial of 5 is 120. So we have here only one trailing zero. Now if we divide this number by 5, then we're left with 1. And then we're going to add that 1 to this count variable. So count became 1 for next iteration of this while loop. For next iteration of this while loop, number is greater than 0, but n divided 1 is 0. So it will add 0 to this count, so it remain as it is 1. And for the next iteration, we see n equals to 0 and 0 is not greater than 0. We are into this while loop, we'll just return this 1. And this is how we can solve this problem. And this solution takes bigger of log 5 ways n, where n is the given number, and this is the time complexity for this problem. And this is 5 ways log, okay? And it will take constant space complexity since we're just using one variable count. Alright guys, hope this concept was clear. If you have any question, if you have any suggestion, let us know. Thanks for watching this video.